Okay, so now that we've got our stretchy IK in place on our arm, let's talk a little bit about how we can adapt that to have a stretchy FK setup and blend back and forth between stretchy FK and stretchy IK. We'll also then discuss how we can go about locking that stretchiness on the arm. And then in the next video, we'll turn around and implement what we talk about in this video. So I do want to jump over to the whiteboard. Let's bring up a new layer. And grab my brush, fantastic. So we saw that we have our stretchy IK on our arm currently, which means that if we move our end effector past the total length of the bone chain, those bones are going to stretch to reach to the end effector. Now we could take the same approach as we did with the IK on our leg and give ourselves some manual control as well, giving us an upper stretch and a lower stretch. And that would be the exact same thing that we already saw when we set up the leg. So that's going to be our IK stretchy setup. But we could adapt this and we could apply this to an FK setup. Now obviously with FK we don't have an end effector, so it wouldn't make sense to have a position of an end effector affect the length of our chain, since the end effector doesn't affect anything to do with FK. However, we could implement manual parameters for an upper stretch and a lower stretch that are utilized with FK. So when we have FK, let's note that this is indeed IK. When we have FK, we could create manual parameters for our stretchiness. So again, we'd have an upper stretch and a lower stretch when dealing with FK. And these would be unique parameters from the IK ones. They would allow us to change the length of the upper and lower arm bone, and then the rotations on the controls obviously would drive the orientation of those bones. So that would give us the ability to have a set of IK stretchy parameters and a set of FK stretchy parameters. But how do we go about blending between these? Well, really, for each bone, for both IK and FK, we effectively have a stretch factor which we take and we multiply by the original bone length, and that will give us the stretched bone length, the final bone length. What we need to do is we need to linearly interpolate between the stretch factor for IK and the stretch factor for FK before we multiply that in with our bone length. We saw linear interpolation when we dealt with locking the stretchiness on our leg. So let's now take a look at how we can apply linear interpolation to blending between the stretchiness on our IK and our FK. That means we're going to need some kind of parameter that goes between 0 and 1 and controls that interpolation. In this case, I'm going to name that parameter blend. And blend is going to go between 0 and 1, where 0 is equal to FK and 1 is equal to IK. So we have that in place. That means if we want to have FK, then we're going to need to have 1 minus blend and multiply that by our FK stretch factor. And we can see there that when blend is set to 0, is set to FK, 1 minus 0 gives us a value of 1. That gives us 1 times our FK stretch factor and gives us 100% of that FK stretch factor. However, when we blend over to IK, 1 minus 1 is equal to 0. We take 0 times our FK stretch factor, giving us none of our FK stretch factor. If we take that and we add to that blend, and I put that in brackets, but it doesn't really need to be in brackets there, multiplied by our IK stretch factor, we can see that when we have a blend value of 0 is set to FK, well 0 times our IK stretch factor is equal to 0. However, as we blend over to IK, whilst our FK stretch factor gets blended down towards 0, our IK stretch factor gets multiplied by more, eventually is multiplied by a value of 1, giving us 100% of our IK stretch factor. So that's going to allow us to blend back and forth between FK and IK. If we were to take this and multiply it by our initial bone length, that would give us the final bone length that would blend between stretched IK and stretched FK. However, we also need to be able to lock the stretchiness on these bones, and that's really simple. What we can do just as we did with the leg, we can create a lock parameter. So we can have a lock parameter where if lock equals 0, that means we have no stretchiness. And if lock is equal to 1, that means that we have 100% stretchiness. We again can use linear interpolation, and in this case we want to blend between the result of this expression and a value of 1. We want a value of 1 when we have no stretchiness. So when lock is equal to 0, we want a value of 1. And we want a value of that expression that we set up that blends between fk and ik, which we can think of as being our stretch factor, our blended stretch factor, if you will. We want a value of that when lock is set to 1, when we are indeed having stretchy bones. So we can take our lock and we can say 1 minus lock. We could multiply that by 1. Well, anything multiplied by 1 is itself, so we'd have itself. That would give us our no stretchy situation. We could then add to that lock multiplied by what I'm going to call our blended stretch factor. Which in actuality is that expression right there. So we can multiply lock by that blended stretch factor, giving us our 100% stretchy. We can take all of this, and if we were to multiply that by our eye length, that would give us the final bone length that we need. If we're set to 0 on the lock, we're not allowed to have stretchiness. That's going to give us a value of 1 returned from all of this expression, multiplied by our eye length, gives us our original length back. We don't have any stretchiness. As soon as we're set over to a value of 1, we're getting 100% stretchiness. We'll get whatever is returned from our blended stretch factor as the result from this expression, and that will give us that multiplied by eye length, giving us our stretched bone length. And again, as we blend between fk and ik, that's going to blend the result of this expression back between our stretch for ik, driven both by our manual parameters, and the automatic stretch driven by the ik end effector, and also our stretch on the fk driven by our manual parameters. So we've got all that in place. In the next video we can actually turn around and implement this, and implement our stretchy ik fk blending. Thanks a lot.